Okay, question 4 asks us to find the value of the gradient when x is 4 for this curve here. So we're going to need to differentiate this. In order to set it up ready to be differentiated, I'm going to rewrite this as a power. So 4x minus 7 to the power of a half. And I'm going to rewrite, well, I'm not going to rewrite this one. I'm going to use the quotient rule on this part. You could rewrite it and use the product rule, but they tend to set questions up on purpose for the quotient rule. If you don't want to remember the quotient rule, you can do this by using the product rule. So dy by dx. We're going to pretend this is an x, move the power to the front. Take 1 off the power, and then times by the differential of the bracket. So we're going to times by 4. I'll tidy all this up afterwards. The quotient rule for this says differentiate the first term or the top term and leave the bottom term alone. Minus, leave the first term alone and differentiate the bottom term. So that's just going to be a 2. And divide it by the square of the bottom. Okay, so if we do tidy all this up, we're going to have, we've got a 4 over 2, so that's going to be a 2. 4x to the minus a half is the same as divided by the root of 4x minus 7. And then we're going to have plus 8x and a minus 8x here as well. So they're going to cancel. So we're just going to have plus 4 on the top over 2x plus 1 squared. And it wants us to work out the value of the gradient when x is equal to 4. Notice it says the exact value, so it's not going to want you to use your calculator. You're going to want to do this just mentally to keep everything in exact form. 4 4s are 16. 16 take away 7 is 9. So, and we're square rooting that, so that's just 2/3. So we've got 2/3 plus 9 squared, so 81. So 2/3 plus 4 over 81. You can use your calculator for that actually, because it will give it you in exact form. So I've got 58 over 81.